we're good. Uh, Hello and happy Monday. I am Professor L, and this live stream is for math help. So, yes, please, viewer, encouragement here. I need math problems to work. So, I am working every day to try to keep content going so that I can get practice presenting. But I am encouraging viewer participation strongly. And so, just a reminder that if you do have a subject that you want to see presented, or if you have a problem you would like to see me work on, you're welcome to post it in the chat and I'll look at it. In the meantime, again, I have found a problem to work on. This one is involving, again, we're still in trigonometry land and right triangles. And I actually, for the first time, meant to get my board erased and just didn't get to do that. I had to use it as a prop for a photo, so I'm trying to get my social media going, and so I wanted to use my own original picture and my own props. So that's what this is about. It's just a bunch of formulas that I could think of at the top of my head and math related scribbles. So there's a lot of marker to erase. So I do apologize for that. So let me go ahead and just get into it. So right triangle applications involving trigonometry usually involve solving for and having to know either an angle theta, and you need to at least have an angle and a side length or two side lengths known. And it's pretty much the gist of it. And then there's a lot of applications in triangles that are not right triangles too. So that might be something that we get into next. I prefer it to be student-led. So I prefer to remain useful. So if there are students out there that are struggling with math, part of me offering up this live space is so that I can be useful. Hopefully I'll help someone. All right, so let's go ahead and title this one. We'll just say right triangle applications. And then I will say estimating the height of a building. But it could be a building, it could be a tree, it could be anything. And so what we have is, and I don't want to write this whole problem out, but it's a tower that stands on a cliff 653 feet above a horizontal plane. So we have a horizontal plane. And we have a cliff that is 600. So we'll just say this cliff is 653 feet. And it says from a point A tower stands on a cliff. So there's a tower. So we'll say a tower. It could be like an antenna. Something like that. So we got a tower. I got a little carried away. I want to do a little bit better job of this. We're gonna go with this. We'll say, could be one of those, like watch, look out. It has, could have like one of those staircases that wind up the side of it or something. There. So you've got this cliff and you got a tower on top of it. And it says, from a point A in the plane, so from a point A in the plane, the angles of elevation of the top and bottom of the tower are 47 degrees, 28 minutes, and 43 degrees and 36 minutes, respectively. How high is the tower? And I posted this problem today, so I do have it posted in writing. I just don't want to write it again on the board. So I took a picture of it and posted it, and then, so hopefully that's good enough. All right, so we have an angle, theta. So let's see, I might go ahead and get my yardstick here. I can find one quickly. See if we can get pretty good. So I'm gonna go ahead and draw through the center of this one. So I'm gonna say we want a straight line because we want a perpendicular. So we're gonna go ahead and draw that line there. And here is this distance. And then we need this distance. And it's saying the angle of elevation. So that going to the bottom of the tower, which will be the top of the cliff. So we have this angle, theta, and then it says to the top of the tower from this point. So we also have this angle. So this we'll call this theta 2. Theta sub 1 and theta sub 2. And it's saying how high is the tower? So we've got this tower here. So we're looking for this distance. We're going to call it x. Okay. Let's call it h for height. That'll be better, wouldn't it? All right. So we don't know this distance. We would call this one x because this is the horizontal axis. So we would label that one x. All right. And so I have not plugged this one into Google yet because of the fact that it was an odd problem. So I was able to see the solution. I don't know how the official way of solving this is, because whenever I solved it, I just had my own way. I got the right answer. So I don't know. I should go ahead and after this is done, I'll go ahead and plug it in. But what I did was I found this value. So I found this distance, and then I used this distance and this distance to find this one. So we have theta sub 1. We'll go ahead and list those. So that first theta, it was given, and theta sub 2 was also given. 47, 28. Let's see. So we'll say theta sub 2 is the larger angle, so that's got to be 47 degrees and 28 minutes. Oops, not 21, 28 minutes. And then theta 1 was a smaller theta. That's going to be 43 degrees and 36 minutes. And what I really want to do, I kind of just put these in decimals that way, but we'll just go with it. All right, so my first equation I'm going to set up is going to be involving an opposite over adjacent for the smaller triangle. So let me just draw the smaller triangles and show you what I'm talking about. So we've got theta sub 1, and we've got 653 and x. And we don't need to know this distance. So we're going to use tangent. So we're going to say tangent of 43 degrees and 36 minutes is going to equal opposite over adjacent. By definition, using the tangent function. And so we're going to say tangent, and then we put this over 1. We could even cross multiply. That's going to give us x tan 43 degrees 36 minutes equals 653. And then we're going to divide off the tan from x, 43 degrees, 36 minutes. And we're going to do that equal operation to both sides. And you're going to get tangent 43 degrees, 36 minutes. 653 divided by that quantity is going to give you x. So x equals 653 divided by tan of that angle, 43 degrees and 36 minutes. All right. And that's going to give us this distance here. And so I will plug that into my calculator. And let's see what it tells us. 653 divided by 10, 43 degrees, 36 minutes. And I'm getting x to equal approximately 685.7175523. And that's for x. So we're just going to approximate this. to be 686. 686. And really, let's go ahead. I changed my mind. Let's go ahead and just keep it out to 2 decimals for now. 7.2. All right. So now what we're going to do is we're going to make a bigger triangle. So now we have this bigger triangle we're dealing with. And so we're going to put it here. So we have this theta sum 2 that is this entire length here. So what I did was I just made a slightly taller triangle. Theta 2. And it looks like my marker not pick up very good. And again, it's a rough sketch, but this is your right angle. I should draw that right angle in there. You can do better than that. Okay. And I'm going to say that this is 653 plus x, or plus h. 653 plus h. This entire distance here. And then we're going to say that this distance here is 685.72. So when we write our equation now, we're going to use tangent again. Only instead of 653, we're going to say 653 plus h. So that's what this is going to look like. We're going to say tangent, and see if I can write a little bit smaller because I had to write tall. 47 degrees and 28 minutes equals opposite, which is 653 plus h, over adjacent, which is 685.72. So we're going to multiply this quantity by both sides. 685.72. And then this is going to cancel. And then we're going to abbreviate this 685.7 times tangent of 47 degrees, 28 minutes. That equals 653 plus h. And then we're going to subtract 653 from both sides. So let's go to 0, and you're going to get h equals all of this minus 653. So let me write it out down here. So we'll say h equals 685.7 times tangent 47 degrees 28 minutes minus 653. So h equals approximately, and I'm going to plug all that into the calculator. And I'm getting 94.45. We'll just put it all the way out there. 45590,179. So we're gonna say the height is approximately 94.5. So we'll just round to say 94. Feet. Again, if this is if you knew some other values, and again, if you want to read the entire paragraph of the problem, you can look. I've posted it, and I think I posted it on my Facebook page, but I'll go ahead and post it on this one. And I was trying to start doing that, trying to learn how to use other medias besides YouTube. But anyway, it's taking it day by day. All right, so we'll go ahead and stop there. Keep it kind of short and sweet. Another right triangle application problem, and I will be back here, same place, same time tomorrow, and see what I come up with tomorrow. Again, if you watched my video, thank you so much for watching, and I will see you again next time. Bye.